Hello, welcome to ET 454 Project Management. My name is Dr. James McCurahan. In this lecture, I'm going to talk about 4 different types of life cycle management approaches. This lecture is important to you as a student because you will need to decide on what type of approach you will take for this semester-long project. You'll need to decide with your 3 group members whether you want to use an predictive approach, an adaptive approach, or a hybrid approach. But enough for that now. I'll talk about that in a number of slides to come. In this slide, I'd like to talk about the different types of life cycle approaches. The first approach is considered a predictive approach. It's also called the traditional approach and a sequential approach to project management. Other terminology associated with it is the waterfall approach or the stage gate or phase gate approach. Underneath of Agile is the iterative approach and the incremental approach. It is most closely associated with being iterative for the Agile approach. Finally, there's the hybrid approach, and the hybrid approach would just means that you would use a combination of the predictive approach and the Agile approach. Okay, so the waterfall approach, stage gate, or phase gate approach. The waterfall approach is a sequential linear project management method where progress flows in one direction, like a waterfall, and through distinct phases. Those phases include requirements, that would be listing what needs to be done for the project to come to completion, the design of the phases and the things that need to be done during those phases, the implementation of the project itself, going through those phases or the stages to complete what's required for an outcome, verification to make sure that you've done what you've set out to do, and then maintenance. That would be either the tweaking of the requirements or tweaking to get to those requirements, or even just the maintenance of the project after the project is done. Some key characteristics include each phase must be completed before the next phase begins. There's no overlap between phases. There's little flexibility for changes once a phase has been completed. This type of approach is ideal for projects with clear, stable requirements. For instance, construction approaches and even some software development approach. The pros: it's easy to understand and manage. It's clearly defined stages and deliverables. It's good for documentation and regulatory compliance. The cons are it's not very flexible for change. Issues are often found later and they are expensive to fix afterwards. And it's a poor model for iterative or evolving approaches. In the following slides, I will provide you examples of waterfall approach projects. So the first one, as I talked about before, is construction projects. For instance, building a house or a commercial structure. Why waterfall works here: each phase you'll have blueprint, the design, permitting, building of the foundation, framing of the structure, then you'll put in the electrical, the plumbing, do the drywalling or finishing the walls, then you'll have inspection, and they must be completed in order before you can move on to the next phase. Again, the requirements are fixed early on. For example, you'll know the square footage of the building you're going to build, the materials you're going to use, and the design that you're going to use. Another example is traditional software development. For instance, developing a firmware or a software for an ATM. Simply repetitive access and use internet site systems, an app or application on your phone, or an embedded system. Why waterfall works here: the requirements. For instance, for security, for input and output functionality, it's simple inputs, simple outputs, and they're known well in advance. There's no need for frequent user input or iteration. In other words, once it's there, it's pretty standard. There's no variation upon what needs to be done with it. And then extensive testing is done after the full development. Here's another example of a waterfall approach, installing equipment in a manufacturing setting. Why waterfall approach works here? Steps like equipment selection, floor planning, electrical setup, installation, process flow, and testing are all sequential. Any mistakes or missed steps can be costly to compensate for or to reverse. Here's another example of a waterfall approach. Textbook manual, a textbook or manual publishing, or even lecture preparation. Writing and publishing a novel, training guide, work instructions, or even a school textbook. Why this works here? The flow is pretty standard. You have content development, you write it, you edit it, you determine the layout and design, then it goes to print, then it goes to distribution. There's clear review points, but little iteration once content is finalized. Another example, federally funded programs and activities, or even defense projects, they're good for the waterfall approach. Example, building a missile defense system or running a census program. Why waterfall works here? Requires strict documentation, traceability, and compliance. There's detailed specifications. They're all defined up front and typically due to legal and safety considerations and constraints. Hardware product development is another example of the waterfall approach. In this example, we're designing and producing a new model machine, like a car. Why the waterfall works here? It involves clear stages, conceptual stages, the engineering design stage, prototyping, tooling, and then production. Late changes, though, are expensive, so the design must be finalized early. The automobile industry does very good with this because they change models from year to year. A summary of the waterfall approach. Waterfall approach works best for projects where requirements are well understood. Each phase builds on the last stage. It utilizes recognizable milestones and milestone events. And by the way, the term milestone is closely associated with the waterfall approach, phase gate or stage gate approach. A milestone is a significant point or event that marks progress towards the completion of a project. It's not necessarily measurable, it's just something that is substantial towards completion of the phase. And then finally, changes during execution are costly or disruptive, and they need to be avoided if possible. Stage gate or phase gate approach is similar to the waterfall approach, but a stage gate is a project governance and decision-making process that breaks the project into stages separated by gates or review points. It focuses on the go, no-go decisions at the gate, whether or not to proceed. There are two parts to the stage gate or phase gate approach. Typical structure is as follows. There's the stages, which are the work phases, where tasks are completed. For instance, there might be the concept development phase, and then the feasibility phase, then the development phase, then testing phase, and then launching phase. And then there are the gates in between those phases. Those are control points where decisions are made, whether to continue on to the next phase, whether to hold at that phase and fix the problems, whether to revise the phase, or whether even to kill the project. Some key characteristics are They're designed for new product development and for research and development heavy environments. This type of approach emphasizes business evaluation, risk assessment, and cross-functional decision making. It can also integrate waterfall or agile methods approach within each phase. The pros to this are it prevents wasted investment in poor ideas. It encourages thorough evaluation and planning. It reduces risk through progressive commitment, and it aligns stakeholders at each gate. Some cons to this approach include can become bureaucratic if not implemented effectively. The gate reviews may delay progress. They're less suited for very small or agile teams unless they are tailored well. Another example might be new product development in the automotive field. For example, designing a new electric vehicle model or all new automobile. Why stage gate works here? The phases are consistently the same. You have the concept, feasibility, prototype, pre-production, and then production launch. The gates ensure technical feasibility, budget approval, and market analysis before large investments. And then it involves cross-functional input from engineering, marketing, supply chain, and it's needed at each gate before proceeding to the next phase. Pharmaceuticals development is another example of stage gate or phase gate. For instance, creating a new prescription drug. It follows strict and distinctive phases. There's the discovery phase, preclinical, clinical trials, regulatory approval, and then the launch phase. The gates allow stopping or pivoting if results are poor or unsafe, and it reduces the risk in high cost and high regulation environments. Another example of stage gate is consumer electronics product launch. For instance, launching a new smart home device. Why stage gate works for this? Gates are used to evaluate the market to see if it's large enough. The prototype and if it is functioning well. Is it manufacturing scalable? And whether or not there is alignment with R&D, marketing, and customer at every step of the phase and at the gates. Another example of stage gate or phase gate use is fast-moving consumer goods innovation. For example, developing a new laundry detergent formula and its packaging. Why it works here? It involves concept testing, lab trials, consumer panels, packaging design, and then rollout. The gates filter out unfeasible or unprofitable ideas before the product goes into mass production. A tech startup product pipeline is another example of the stage gate or phase gate approach. In this example, a startup launching multiple software service products is being provided. This might include development of Facebook, Google, Google Workspace, Salesforce, Plex, and Netflix. Why the stage gate works here? Each new product goes through the same process. There's the ideation phase, then the minimal viable product determination phase, beta testing, market fit, and then full launch. Investors and leadership assess each gate to green light for the funding or pivot, or even to stop the project. Another example here is industrial equipment design. For example, designing a next generation robotic arm for humans or for factories. Why stage gate works here? It involves engineering design, simulations, prototyping, reliability testing, and customer trials, all in that order. The gates here help prioritize development and pass and prevent resource waste. University R&D commercialization projects are another example of stage gate or phase gate approach. In this example, technology transfer occurs involving large fracture plugging of oil drill holes from university to the private sector. Why the stage gate works here involves engineering design, simulations, prototyping, reliability testing, and then customer trials in the field. The gates help prioritize development and pass and prevent resources wasting once again. Here's a summary of the stage gate or phase gate approach. It provides for structured risk management. It breaks the project into manageable stages, with gates acting as decision points. At each gate, the project is evaluated for technical, financial, and market feasibility. It prevents wasting time and money on weak ideas or failed concepts. It provides for better strategic alignment. This approach ensures the project is aligned with business goals and customer needs at every part of the project. Cross-functional teams, for instance R&D, marketing, and finance, are used and participate in gate reviews. This approach promotes informed strategic decision making. Now on to the Agile product lifecycle approach. In this, we'll discuss the iterative phase and the incremental phase, with iterative being more closely associated to Agile project lifecycle approaches. In this slide, I just want to discuss terminology that's common to incremental, iterative, and hybrid approaches. The term Scrum is often used, but it's more closely associated with the iterative approach. A Scrum is a popular Agile approach management framework used mainly in software development, but also in other industries. It's designed to deliver products incrementally and iteratively through short, time-boxed cycles called sprints. And sprints typically last from 1 to 4 weeks. It's not structured. They're not sure how or what needs to be done or the volume of work that's going to be done, but they know when they get there that they're done. Okay? I have over here an example of the Scrum process, and we'll talk about this later. There's also the Kanban. Kanban is a visual workflow management method that helps teams to see what's being worked on. It keeps track of work in progress. It also helps with understanding the tasks and their status. It helps to identify bottlenecks in the project. It also it uses improved project efficiency over time. Here's an overview of the incremental approach. The project is divided into smaller, deliverable parts, and each increment is related to, but does not necessarily depend upon, the previous ones. It is considered an adaptive approach which embraces change and uncertainty, particularly in environments where requirements are challenged or evolve rapidly. The individual portions to the whole of the project can be added to. Unlike Waterfall or Agile Iterative, incremental delivers functional components gradually, adding functionality step by step. Here's some characteristics of the incremental approach. Delivers in small functional increments. The project is divided into manageable parts, which are increments. Each increment adds a working feature or an enhancement. Earlier increments may be basic, with complex ones to follow. It has early delivery or usable results, so partial functionality is delivered early in the project's life cycle. Users or stakeholders can begin using the system even if it's not fully complete. And it builds upon previous increments. Each new increment can add to and improve the previous one. The product becomes more complete and feature-rich over time. Furthermore, it involves easier testing and debugging since it's broken up into individual sections. The testing is done after each increment, making it easier to catch and fix issues early. Supports modular testing of components. Furthermore, it involves user feedback integration. Users can test earlier increments and provide feedback. This input can influence and improve later increments. It's flexible to change since not all functionality is built at once. It's easier to adapt to changes. Later increments can reflect updated requirements or priorities or customer wants and needs. It's cost and time efficient. Early increments can be delivered and used while development continues. Projects don't have to wait until the end for value to be realized. And then finally, it involves stakeholder engagement. Frequent delivery and feedback keeps stakeholders involved and informed, and it builds confidence and alignment through the project through the life cycle. If you notice at bottom right, I supply an example of burger building. It's a good example for the incremental approach. If you notice, you have a plain hamburger. There's the bun and the meat. Then you might add cheese to it. Then you might want to add cheese and ketchup and provide those as selections for orders. Then you might want to say you can have it with lettuce. Then you might call it with the garden. And then it might be with the garden and a tomato. And then it might be loaded and has everything to offer. Here are examples of incremental project management approach. Development of a mobile banking app. The increments might be initially just providing a log on or log in and basic review of an account. Then you might provide the funds transfer between accounts function. And then bill paying and mobile depositing, and then fraud alert and chat support. Each feature is delivered as a working product that builds on the previous release. The next example is an e-commerce website, kind of like Amazon. Increments might involve product listing and browsing, shopping cart and checkout, user account and order history, product reviews, recommendations, and chat support. This method allows early sales while adding features gradually. And then smart home system. Increments might be providing automated basic lighting control, then thermostat and temperature control, then automated security system integration, and then even voice assistant support and control of the previous 3 increments. Each increment increases usability without waiting for this full system to be complete. Another example might be online learning platforms. The increments might be course content viewing and reviewing, quizzes and progress tracking, discussion forums, instructor feedback and certification, where each increment delivers more value to the learner. Next, public transportation ticketing systems. The increments might involve bus ticketing for one city, integration with metro lines, integration with regional rail lines, mobile app with real-time updates of the transportation lines. The system evolves as more transit modes are integrated. The pros and cons of the incremental approach. As for the pros, apportioned work, early delivery of value, provide segments one at a time of the project, reduces risk per increment, enhanced feasibility, use of feedback, easy adjustment to changes, and flexibility mid-project segments. Stakeholder engagement per each segment. Modular development and testing, focus on individual components and debugging segment issues. And then the cons, it requires clear architecture. There's integration challenges with complex interdependencies. There's partial product perception. Some segments may be good, some may be bad. Scope creep and planning difficulties can occur. Overhead, management complexity, and frequent reviews and testing. Segment-to-segment segues are difficult. The following is a summary of the incremental approach. The incremental approach divides a project into smaller, manageable parts, or increments. Each increment adds a functional component to the previous one, or individually, until the final system is complete. Some key characteristics of it are the project is split into independent increments that are developed and delivered one by one. Each increment is a complete mini-project with its own planning, development, and testing. Earlier increments are fully functional and stable. Later increments build on earlier ones, enhancing the product. User feedback is often used to guide future increments, and it delivers value early and consistently throughout the project. An overview of the iterative approach is as follows. The iterative approach method is executed in repeated cycles or iterations. It is considered an adaptive approach when it embraces change and uncertainty, particularly in environments where requirements are challenging, evolve rapidly, or are difficult to define upfront. It uses the trial and error approach to find stuff out to build better products and projects. Each iteration delivers a working version of the product, which is reviewed, refined, improved in the next cycle based on planning, feedback, testing, and evolving requirements. Unlike linear models like Waterfall, the iterative approach embraces change and continuous improvements throughout the project lifecycle. How it works on an iteration: there's planning, analysis, design, development and implementation, testing, and then review and evaluation. Key characteristics of the iterative approach are as follows. This approach breaks down large projects into smaller, more manageable iterations called sprints, with the goal of continuous improvement and adaptation based on feedback and results. Unlike linear methods, like the waterfall model, the iterative approach involves repeated cycles of planning, execution, testing, and evaluation. Each iteration builds upon the previous one. It emphasizes flexibility, allowing for change to be incorporated throughout the project lifecycle. It requires feedback from various sources, including users, testers, and stakeholders after each iteration. It's particularly beneficial for projects with evolving requirements. They're not quite set in stone, or complex or uncertain environments, or those in industries that rely heavily on continuous improvement and user feedback, such as in software development, product design, engineering, and marketing. Furthermore, it delivers a working product at each stage, yet is improved upon or tweaked at each stage. For you gearheads, this might be working on a car and trying to get that engine output to be better and better and better. You stay up all night, you keep tweaking the engine over and over again. Okay, next, product is refined through multiple iterations. Each cycle improves functionality, design, or performance based on feedback. Changes and refinements are expected and encouraged. Flexibility is built into the process to accommodate new ideas or to make corrections. The final system evolves over time. The complete product is the result of many improvements, not just a single build. Here's some examples of iterative project management projects. Software application development, building a new email platform. Website redesign, revamping a university website. Product prototyping and engineering, designing a new smartwatch. Game development, creating a role-playing video game. Mobile app development, making a fitness tracking app for your phone or your computer. Curriculum design for education, creating a new STEM curriculum. Marketing campaign development, for instance, a product launch campaign. Here are the pros and cons of the iterative approach. Pros: early delivery of value. Functional versions of the product are delivered early and regularly, providing quick wins and enabling stakeholder feedback. Continuous improvement. Each iteration incorporates lessons learned from previous cycles, improving quality and alignment with requirements. Flexibility to change and adjustments can be made throughout the project without needing to start over, making it ideal for projects with evolving requirements. Risk management. Risks are identified and mitigated early due to frequent testing and stakeholder reviews in each iteration. Stakeholder engagement. Regular interaction with customers or end users helps ensure the product meets expectations and reduces the likelihood of major surprises at the end. Improved quality. Frequent testing and reviews throughout development catches errors early, leading to more polished final product. Some cons involved are inherent scope creep. The flexible nature can lead to uncontrollable changes or expansion of scope if not carefully managed. Further, incomplete planning. Initial planning is often high level. Without a clear final vision, the project may veer off course or go over budget. Dependency on frequent feedback. The process relies heavily on active and timely participation from stakeholders, which may not always be feasible. It requires higher resources demand, means more frequent meetings, more reviews, and more revisions, and those revisions can require additional time and personnel, increasing overall effort and sometimes costs. Not ideal for all projects. Projects with very fixed requirements or regulatory constraints, for example, infrastructure or government projects, may not benefit from iteration approach. Can be time consuming. Constant refinement and testing may delay final delivery if not tightly scheduled. In summary of the iterative approach, the iterative approach is a project management method that develops a project in repeated cycles. Each cycle includes planning, designing, building, and testing a refined version of the product until the final version is achieved. Key characteristics include builds from a simple version and improves it over each iteration over time. Each iteration includes complete development phases: planning, designing, implementing, and testing. It's feedback driven. Changes and refinements are encouraged after each cycle. It's flexible and adaptive to changing requirements and environments. Finally, the final product evolves through learning and repeated improvements. Finally, the last approach to discuss, the hybrid approach. Here's an overview. The hybrid approach to project management combines elements from two or more traditional and agile methodologies to suit the specific needs of the project. It aims to take the strengths of both structured and flexible approaches to improve planning, adaptability, and overall outcomes. What does hybrid really mean? Typically, a hybrid project management approach blends predictive or traditional methods like Waterfall or stage gate, which are structured and sequential and emphasize upfront planning, with adaptive methods like Scrum or Kanban, which are iterative Collaborative, and respond well to change. This allows teams to manage different aspects of a project differently, for example, using a traditional approach for overall planning and compliance, and agile techniques for development and delivery. Notice the bottom right-hand side, I provide an example of a waterfall and agile project management approach. At the very beginning, we see the planning. Then we have a scrum, which is actually part of the agile process, but falls under the waterfall. So there's initial requirements discussion, analysis, and then design. And then the initial project and backlog, and we'll talk about a project backlog. We'll talk about sprint plans later. Then we have the scrum, and within the agile sprint, we have the design, build, testing, and then partial output. And then we have scrum review, and then we have quality assurance, and then deployment of the final project. Some key characteristics of the hybrid approach include combination of predictive and adaptive planning. High-level planning is most likely done up front, like with the waterfall approach. Detailed planning and task execution follow an iterative or agile style. This allows fixed timelines with flexible delivery. Next, define project phases with agile execution. Projects may clear phases, including initiation, planning, execution, and closing. And within each phase, especially execution, agile practices, sprints, iterations, and stand-ups are used to deliver work. Flexible and customizable framework. Teams can tailor processes, tools, and techniques based on the project type, industry, or team capabilities. Further, there's no single set way of doing this. Next, stakeholder engagement throughout. Traditional checkpoints, milestones, sign-offs are preserved. Agile style customer collaboration and feedback are also integrated regularly. And then risk management throughout dual methods. Risks are addressed early via predictive planning. Agile feedback loops help identify and adjust to new risks during execution. More key characteristics of a hybrid project management approach include use of multiple tools and practices. It may include Gantt charts, work breakdown structures, critical path analysis, along with user stories, Kanban boards, or daily stand-ups. Must have cross-functional team collaboration, encourages strong collaboration amongst departments and roles, and may work under different expectations. For instance, engineering has to be agile, compliance, waterfall. Incremental delivery with long-term vision, supports released working components incrementally. Progress is visible yet aligned with long-term strategic goals, milestones. Enhanced change management. This method accommodates changes mid-project without derailing the overall plan. And 10, agile segments absorb change. Predictive oversight keeps the big picture on track. Must have strong project governance, maintains visibility, documentation, and accountability, often required in regulated or enterprise environments. Here are some real-world examples of hybrid project management approaches. Software development in a regulated industry, in other words, healthcare, information technology. A company develops an electronic medical records system or software for hospitals, has waterfall approach user elements, upfront regulatory documentation, data security planning, and compliance milestones. Then agile approach is used and development of user-facing features, iterated in 2-week sprints, developed or based on doctor and nurse feedback. And then the outcome, a predictable schedule for audits and certifications with agile flexibility for user needs. Another example of hybrid approach is automotive product development. An automotive manufacturer designs a new electric vehicle charging system. It uses a waterfall approach to use elements. Engineering requirements, safety testing, and manufacturing plans are tightly controlled and planned up front. The Agile elements to it include software systems like infotainment or navigation, and those are developed using Agile sprints to respond to UI, UX testing, and features updates. And then the outcome, the hard deadlines for manufacturing are met while following flexible, modern feature development. Another example of hybrid approach is construction of project with smart home technology integration. This can be similar or different to another example provided earlier. A contractor builds a smart office building with automated light, HVAC, and Internet of Things control. The waterfall approach use building architecture, permits, and physical construction. The Agile elements to it include the Internet of Things system and automation of software, where testing and development's done in stages and during late construction. And then the outcome, meeting building codes while allowing cutting-edge technology integration closer to delivery. Here's another example. Online learning platform for a university or improvement of its portal. ISU to develop an online learning portal during a major digital transformation. Waterfall approach used, curriculum improvement and approval, accreditation alignment, and IT infrastructure deployment. Agile elements include UI, UX, student dashboard, course interaction features built iteratively with input from students and instructors. And then the outcome meets student and faculty needs and accreditation deadlines while continuously improving the product and user experience. Pros of a hybrid project management approach. Flexibility with structure. It allows teams to follow structured planning and control where necessary while enabling an agile flexibility for changing needs or innovation. Better risk management. Risks are addressed early through traditional planning, and emerging issues are quickly adapted to through iterative review cycles. Improve stakeholder satisfaction. Stakeholders benefit from regular updates and working deliverables while still having confidence in long-term planning and milestones. Increased efficiency across teams. Teams can operate in the style that suits their role best. For example, hardware teams may use Waterfall while software developers use Agile. Faster value developed and delivered. High priority or customer-facing features can be developed, delivered, and refined early. Even back-end work continues under a predictive model, ideal for complex or evolving projects, great for large multi-phase projects where some requirements are fixed and others evolve over time. Supports organizational transition, easier for organizations moving from traditional to agile to adopt incremental change rather than shifting everything all at once. Some cons of hybrid project management. Complex implementation. Managing two or more methodologies in one project can create confusion, overlap, misalignment, especially without precise planning and governance. It requires skilled project managers. The success depends on the PMs who deeply understand both agile and traditional approaches. Inherently consistent communication patterns. Teams working under different approaches might face communication breakdowns or mismatched explanations. Further difficulty to measure progress uniformly. Tracking overall project status can be tricky when agile teams use velocity sprints, while traditional teams typically use milestones and Gantt charts to keep track of their progress. There's potential for scope creep. Agile's openness to change, if not properly controlled, can lead to vast scope creep in the project. Tools and process integration issues. Using different project tools or systems can make integration and reporting more difficult across platforms and across teams. In summary, for the hybrid approach, the hybrid project management approach is a flexible system that blends the strengths of traditional, predictive, and adaptive methodologies. It's designed to handle complex, evolving projects by applying structured planning where needed and allowing iterative development where flexibility is beneficial. Finally, with the end of this lecture, you should be aware of the types of project management approaches. I've provided examples of them. And now work with your project team to determine the project your team will complete. Realize you can use a traditional predictive approach, which is sequential, and that means you can have traditional waterfall or a stage gate or phase gate approach, meaning that there are going to be checks at every phase. Also, it can be Agile, which Agile is more closely associated to iterative, or it could be incremental, doing portions at a time. And then you can use the hybrid approach, which is a combination of all of the predictive or Agile approaches. Thank you very much, and I will look for you in the next lecture.